This is very, very cutting edge. This is happening right now.
From EE Tech and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. When you think about EV motors and battery packs, you probably imagine big stators and magnets and complex battery chemistries, or at least that's what I think about. But there's a lot of other high-tech engineering and physics work that goes into making motors and batteries efficient and work well. So today in Moore's Lobby, I'm joined by 3M's Global R&D Director of the Electrical Markets Division, Mike Strommen, to dig into the trends in the EV motor and battery world and a whole lot more. Like, we cover so many topics. So let's get into it. Mike, thanks for being here today.
Oh, well, thanks for having me. I'm looking forward to our discussion.
I'm curious, can you give me 3M's view of the world of power and what is your role in that industry?
Sure. I'm going to start just talking about 3M first. 3M's a company that's really based on technologies. And what we do really well is we apply those technologies to high-value problems in growth markets. Obviously, power and electricity is a growth market. The world is becoming electrified. So what we do, what 3M does is, again, what are the high-value problems in the generation of electricity, the moving of that electricity, i.e. the grid, the storage of the electricity, and the efficient use of the electricity. So what we do is, where can our technologies be applied to have the most benefit to the world, really, and ultimately benefit to 3M shareholders, of course.
And you personally have spent a lot of time in the energy industry. How did you first get into technology, and what gets you excited about it today?
I remember when I was an undergrad, the American Chemical Society had a journal called Environmental Science and Technology, and I may have been the only undergrad that read that cover to cover. And I ended up getting my PhD at University of North Carolina, where the editor was. And it was like me meeting my idol when I went out to lunch with him. I just thought that was so cool. So I've always been interested in environmental quality. It's really, since I was young, it's like, life is finite. And what can you do when you're on this planet to actually try to make a difference? And I saw environmental quality as something that was really, really critical. So I really kind of, that and another passion around education have been the two drivers for my career. And I've been fortunate enough, a company like 3M, who sees issues in environmental quality, and energy, of course, is a huge part of environmental quality, and how we generate electricity has a large impact on things like global climate change. 3M, identifies those needs, and we put resources on it. We put our technical expertise towards it. So it's a great place to be to do that. So short answer is, I was jazzed 25 years ago, and I'm still jazzed today.
Love to hear it. So you get a PhD from University of North Carolina. What is your first role or first set of roles out of school? Like, were you hoping to go into research, or were you hoping to go do some more of this like clean air climate work?
It was both. Well, you can do both. So I told you my other passion was education. So, the plan was, maybe I should go into academia, a tenure track faculty position at a university, do research related to environmental quality. But then I talked to 3M, and I reconsidered it. It's like, okay, I'm going to be working with really smart technical people, and rather than doing the fundamental research, I can do something more applied. We're actually producing products that are actually advancing environmental quality, make environmental quality better. So I chose to do that. Now, it didn't mean that education wasn't going to be part of my life. Throughout my career, I've done various things in education, so I've kind of done both. And as a matter of fact, if you're a leader in a company like 3M, being a good educator and somebody that can basically bring people along with a vision is important also.
So when we talk about energy, we often talk about some of these more fundamental topics, fundamental research-based items. But for 3M, when I first heard, we're doing a 3M keynote, it's like, what is 3M doing in a power engineering discussion? But as I thought further, it made a lot of sense. Could you kind of cover for me what is 3M's role in the world of power electronics, and what sort of things should engineers be thinking about that they maybe wouldn't normally consider when they're first getting into this field?
Yeah, just as an aside, it's for all the markets that we play in, we hear that. Why are the people that make Scotch tape and Post-it notes, in aircraft and in cars and, all these kind of things? But if you know 3M, it totally makes sense. So let's go to energy, essentially. So again, back to what I said before, you need to generate electricity, you need to do it efficiently, and so you need to have, for instance, wind turbines that are reliable, that have, don't have leading edge damage, so that degrades their aerodynamic efficiency. You need to have solar panels that are going to be, durable and reliable. You need to have a grid. We know that, renewables are coming onto the grid very quickly. Potential instability in grid. I'm not going to say that recently happened in Spain. We don't know the reasons yet, but you can see there's grid instability, which is an issue. And, electric vehicles. You have electric vehicles with battery packs. You have safety issues. You have efficiency issues. And motors, as we can maybe talk about later. Again, efficiency and so forth. So what does 3M do? We have tapes. We have adhesives. We have films. We have, all sorts of materials, even to things like abrasives. You say, what do abrasives have to do with power? Well, if you're in a 108-meter long wind turbine blade that needs to be aerodynamic efficient and it needs to last for a long time, you're going to have a whole army of people that are sanding that thing. And oh, by the way, they need to put a respiratory protection from our safety products. And oh, by the way, if they're up tower, they have to have harnesses. So there's just so many things. Early on, when I was leading our wind energy group, we actually had a poster, and we'd bring it to conferences, and we got the same question. And people would look, we'd have all these areas, of a wind turbine, and it would say where 3M products could go. And that alone would be a 2-hour discussion with a potential customer. They're like, wow, I didn't know you guys had all this. This is really cool. And that's really the joy of 3M. One of the things we do, we have here in St. Paul, Minnesota, where I am, we have something called a World of Innovation, which is kind of a museum of 3M technologies. One of the real joys in my job is you bring in a customer that really doesn't understand 3M, you understand their high-value needs, and then you bring them into this essentially museum that has kiosks with the different technologies. And it's really the way we work. It's like, how do you take, you have this issue, you can take this technology and mix it with this technology, and boy, I bet you there's a solution somewhere in there. And their eyes just light up. It's just really, really, really cool. So that was a long answer to what you said. I hardly remember your question, but there's a lot of things 3M could do in power engineering and electrical.
No, that was a perfect answer. And you've also been working with, I think, pretty much everybody in the automotive industry in the
Sure.
world of EVs. Can
Sure.
you talk a little bit about what sort of trends you're seeing in the world of both battery cells and motors?
Yeah. And just as a background, we've had an automotive division in 3M for I don't even know how long, but decades surely. So we've had relationships with these companies. There are new companies, of course, that are just EVs, but a lot of them are companies that did internal combustion. So what do? We primarily, with EVs, we work in the powertrain, and mostly that's around the battery packs and the motors. Obviously, battery packs are new to the world, and the designs are changing quickly. Not only the battery cells, different energy densities, different chemistries, but also the pack designs themselves. Not only for cost, of course, cost down, it's one of the most expensive component of an electric vehicle, but also for safety. Our customers are designing packs differently, they're designing motors differently, but that requires also materials. And again, it's back to the story of, we need materials that can do this. And, this is not an easy thing to do, and it requires combining different technologies. And again, we can get into some examples, but that's essentially what we do. And that's essentially why people partner with 3M.
I'd love to get into some examples.
Sure.
What sort of problems are people coming to you with that there's not an existing solution? And then
let's take one from battery and one from motor. Let's start with battery. Okay, one good one. So a battery pack, if I had a diagram, what you'd see is a bunch of metal parts. There's sidewalls, there's cooling plates, there's the cells themselves, the cell cans themselves. And a lot of them are at different electrical potentials, different voltages. So you have to have electrical insulation separating these. You could use, a standard 3M has tapes. This is a polyester tape with an acrylic adhesive. We have a variety of these, and it provides electrical insulation. And it works great. We have all sorts of backings, all sorts of adhesives. But typically, if a pack does unfortunately go into thermal runaway and it gets up to extremely high temperatures, those kind of technologies, they won't stick. But we do have some materials that can maintain adhesion at elevated temperatures, and they're very, very unique. So that's one thing we do, and it has to be glass cloth backings and it has to be silicone chemistries, and not just plain old silicone, but novel silicones that we've developed. Maintain adhesion, maintain electrical insulation. So the major car manufacturers, again, we're working with several of them on those kind of challenges. Let's go over to the motor side. And I hope you can see this. This is a stator. If people know, I mean, the people who are listening to this know how motors work generally, but you have a stator and you have a rotor. The rotor have the magnets in them. The stator basically have these copper coils. You're running an alternating current through them. And basically the magnetic field is generated through the copper coils interacting with the magnetic field. The magnets turning the rotor. What you're looking at here are the copper coils and the steel core. And between them, the white stuff, if you can see, it's called a slot liner. It's electrical insulation. And typically the way that these are done is they make these cores, and there's these slots that run the length inside here. And they take a paper and they install it with robots down there. And then they install the coils, and then they put a resin. They trickle a resin right through here, and it kind of sucks down through capillary forces in there. And for a century, that's how they make them. So a novel idea is why use a resin? Why not in your paper? Why don't you incorporate the adhesive? You think that's easy? You should be able to do it. Anybody can do that. But it's not as easy as it sounds. You need to now you just have a paper with the adhesive on board. You put it in. Now how do you cure it? How do you make it sure it fills that gap? So you put expandable components in there, expands out, and then it cures and it stays in place. Okay, well now what about you just expanded? You have low thermal conductivity. That's bad. You want to get heat. So how do you increase the thermal conductivity? So there's those kind of things. So again, it's kind of a tape. It's a electrical insulation material. It has adhesive just like a tape, but it's a really novel tape. And that one is huge. I mean, our customers are setting up motor manufacturing, CapEx, new equipment, and they're saying, boy, I really don't want to do the old process where it takes a long time and you have to use ovens and it takes maybe an hour to cure it. Give me your process. I don't have to use that resin. And oh, by the way, I can do this in 6 to 10 minutes. And that's a lot of value. And oh, by the way, it fills that gap and it has performance advantages. So again, a tape that really has a big value.
Absolutely. How many iterations do you go through to get on a final? Here's
great question.
Here's the tape. Like,
yeah.
Can you walk me through that process?
It's a great question.
Start to finish. Yeah.
Yeah, and I'll say it's not random. So not only do we provide prototypes, and you could say, okay, Mr. Customer, here's a prototype, try this one. Oh, that one didn't work. Here's a prototype, try this one. We take a much more engaged approach, I would say. First of all, we have people that can simulate the performance of this. They can build this virtually, and they basically do a digital twin. And you can simulate the entire performance of it. And so it's mechanical, electrical, thermal. You can simulate all of it, and we have those type of people. And then after that, you can, from a simulation standpoint, you could say, okay, these are probably the performance we need. How do you build a product that has that kind of performance? And then you have test capabilities. So we can actually build it and test it. Now, we're doing this in conjunction with our customers, but at least our customers, we can come to them and say, hey, we've looked at your system, and we think this is going to be pretty close. This is probably about what you need. Okay, now let's work together on your real system and your real manufacturing process. So your question is how many? It depends. As always, it depends. Some people have, their designs are pretty similar to someone else that we're working with, and you have kind of a standard product. And, we did iterations to get where we needed, but it's pretty stable. Others are really almost one-offs. They have a novel design, and we try to get pretty close, but there's a few iterations still.
In the world of power, you mentioned digital twins. How much adoption of that have you seen, both on the 3M side, but also on your customer side?
Yeah, great question.
What sort of impact has that had on the R&D cycle?
Yeah, it surely speeds them up. So I know that our customers, for instance, in battery packs, can simulate a thermal runaway event, which is an extremely chaotic process. So you have all these cells that, if they're damaged, can go in a thermal runaway and propagate from cell to cell to cell. And then they need to vent, and they need to vent all these gases and everything, and electrolyte and everything. And so they're saying, how do we design this pack? And they can simulate that. This isn't kind of laminar flow conditions. This is extremely chaotic. But I think it does significantly. They can come to us then and say, hey, we think that this will be kind of the force, and this is the kind of adhesion we need and the durability we need, because this is the kind of challenges that material is going to see. So our customers can come to us on their pack design and say, okay, this is kind of what we think your product needs to do. And then we can supplement that with our simulation. So the answer to your question, it significantly, absolutely significantly reduces cycle time, for sure. And our customers put a lot of effort into that.
So I've also seen a lot of digital twins around motor design and simulating and emulating magnetics and flux flow and all that. Yeah. What sort of trends have you seen lately in motor design versus maybe what you saw 10 or 20 years ago?
Yeah, it's really amazing. My background isn't in motors, so when I started working in electric vehicles, I was just amazed at the creativity and the design changes in motors. Obviously, you have a motor that's on an electric vehicle, and you want it to be light and efficient and so forth. And realizing, like we said before, the most expensive component of an electric vehicle is the battery pack. So if you can increase the efficiency of the motor, you can reduce the size of the battery pack. So any savings, anything you can do to the motor is amplified in terms of the total cost of the electric vehicle. Some of the changes, a big one is in cooling. How do you if you can keep these things cool, you can keep them efficient. So in the past, what they used to do, and again, I have a stator here, and you have a rotor, and they had a jacket that went around the whole thing. And the heat is generated in these coils, and it has to get through our slot liner, has to go out of this core, and then it has to get to this cooling jacket with water that is out there. Lately, what they've been doing is they'll spray a coolant right on these ends, and that's much better. So now your coolant is in contact with where the heat is generated. But still, it's only on the ends of those. These coils extend all the way through this stator, so the inside isn't having the heat generated or taken away. So now they're saying, well, how do we get the coolant closer to those coils? So through the stator, can we have channels that go through that stator where the coolant is? Or even better yet, can I put the coolant so it's touching the coils all the way down? It's running and touching it all the way down. Well, the current technology doesn't allow you to do that. That space is taken. So things like our expandable slot liner, now you can actually not expand in some areas and expand in others, and you can actually keep the coolant going all the way down. This is very, very cutting edge. This is happening right now. Will it work? I hope so. I hope so. It would be a big advance. So those kind of things. The other thing is this whole this stack right here. What I'm touching is not one big chunk of steel. It's actually individual metal sheets that are stacked up to form this. So this may be 300 of these metal sheets here. The thickness of those sheets affects the efficiency. The thinner you can make them, the lower what you call eddy currents are. And any current is kind of a stray current that's in the steel. If you can reduce those, you reduce resistive losses, which is heat losses. So it's very difficult to do that the way they do it today, because they take these metal sheets and they stack them and they mechanically bond them together. They press them together. And when they do it, they can penetrate through the electrical insulation coating on each sheet. But if you were to adhesively bond them, then you wouldn't do that. So 3M is an adhesive, we have adhesive technology. So we're working on adhesively bonding these metal sheets to form. What that does is it reduces these eddy currents, increases motor efficiency, but it also allows you to, for instance, even go thinner in those sheets, which increases motor efficiency even higher. The challenge is, when they're forming these metal laminates, they're punching these out very fast on a manufacturing line. How do you apply a glue, essentially, that can keep up with that, more than 1 per second? And that's where, again, back to the story of, when you think of glue, you don't think of it as high tech. But here you have a glue, if you will, it cures very fast, so it can hold together, and it has the properties you need, so it provides the mechanical properties you need in the motor. So very interesting development. And again, just really ripe for bringing in 3M technologies.
Yeah, I can't imagine just slapping some Bondo in there would work very well, or some JB Weld or something. Yeah.
Right.
You spent a lot of time also doing wind and turbines.
Yeah.
What was the biggest shift in thinking you had to make going from turbines, which I picture as just, massive, to working with EV motors, which are like small and light and nimble? Relatively. Yeah. It's,
just a reflection on that, going between these industries. For a technical person, it's a kid in a candy store. It's so cool. I mean, so in wind, we're working with aerodynamicists and big wind tunnels, for instance, and you're doing things like we had a test system where you take this is my wind turbine blade here. You take a simulated wind turbine blades short, you'd put them on basically a helicopter kind of thing, and you had simulated rain coming down because at 250 miles per hour, a raindrop hitting the leading edge of that wind turbine blade is a very damaging substance. So you're thinking about, how do you absorb energy, in the material? We had a polyurethane tape we put on the top, we still do, and how do you absorb that energy? So there's just really cool thinking that you do. Now you take that over to, a battery pack. You're thinking about, this whole thermal runaway and durability of materials. How do materials like this, when they get hit, with shrapnel essentially at high speed, there's absorbing energy there too, but how do you make them non-flammable? Or, in a motor, again, thinking of this whole cooling thing and heat flow. So there's bringing all these different technologies, and it really goes to kind of, it's a great place to work, and maybe we can go this later. It's kind of like, okay, you have young people that want to get into these fields, what kind of schooling do you need? I need to be an electrical engineer. I need to be a mechanical engineer. I need to be a chemist. It's not that way. It's, to do this well, you bring all those kind of skills together and you create solutions using all that knowledge and skills. So the answer to your question is, when you've done this a while and you've moved from these different industries, applying these technologies, it just recharges you, and it's a fairly big transition, but it's a really cool transition. It's really fun. And our customers, by the way, they expect us to be pretty knowledgeable about this, but they more expect us to be knowledgeable about our technologies. So we're really deep in our technologies, and we understand your needs and your technologies pretty well, not as well as you do, but pretty well, so that we can work together. That's how we play.
I've found so much fulfillment in my career by being able to do more than just electrical engineering that I studied. It's like having those other influences and those other spheres of knowledge has been really rewarding for me. When you look at your teams and you look at the industry at large, what sorts of characteristics do you see that people can develop in themselves to be more successful and ultimately kind of have the same sort of passion that you have for the world?
Boy, I could talk about this for a long time. This is great. First of all, there is kind of understanding different areas, different disciplines, like I just mentioned, for sure. Part of it is, we have hard problems, we have hard challenges. So how do you address a hard challenge? And again, it goes back to education. I think our kids should be given hard challenges that you need to work collaboratively and bring all your skills from different people to kind of come up with solutions to those challenges. So what, I think we should challenge our kids in school to do is exactly what we do every day. So, if I'm hiring someone, first I understand their technical background and so forth, but it's, show me a time that you and a group of people work together to overcome something very difficult and create something of value. How do you create things of value? And how entrepreneurial are you? The other one when I mentor young people, I also say, understand business, but particularly understand finance. It's the one specific one I tell people. There was a senior technical person in 3M who was a wonderful person, and when I was early in my career, he gave me it was essentially finance for technical geeks kind of book, and it was outstanding. So understand that, because we have to make decisions. What's going to be the best use of your resources? We want to address all these problems, but what's the best use of your resources? Which problems should you go after? You're always making decisions. So
that's a good one. I think once I got that insight, and I think I'm still gaining that of, early career, I was like, man, I can't believe they're killing this project. Like, it's so cool. And I was like, but I hate that the words ROI or the letters ROI are coming out of my mouth, but
Exactly.
It's a reality of what we do. Yeah.
You're right. You know what? But my experience with smart technical people is they get that right away. And when they see that, even though they have passions, and we all have passions, especially in this area, and when we're doing, wind energy, solar energy, electric vehicles, I mean, these people are in it. They're in it for a reason. And your audience right now, I'm sure you're all in it for a reason too. But then, when they understand, okay, this needs to be financially viable, and we need to put our own personal time into things that are actually going to make a difference, they get it. they get it. The technical people get it. Yeah.
Absolutely. Yeah. Yeah, that's my experience as well. Since we're on the topic of education and learning, you took an interesting couple-year detour in your career. Can you share what that was?
Yeah, I'd be happy to. I told you earlier, in the late 80s, I was really interested in environmental quality, but I was also interested in education. And at the time, I anticipated it would be, probably university kind of education. So when I became I'm a father of three, and working at 3M, and I was doing renewable energy and everything we've been talking about. I was also doing like after-school science programs and summer camps, STEM camps for middle school girls. We did a lot of things like that, and it really, I started thinking about our model of education, especially with AI coming on, and basically what kind of skills, experiences do our young people need to live fulfilling lives in this century? Because they're it's going to be much different than the way we grew up. So what it really came to is a lot of the stuff we're talking about. How under memorizing every president of the United States or dates of wars or something like that is probably not as valuable as can you create things of value? Can you collaborate? And really, now with with AI and everything, can you challenge yourself? We can customize education for students better than we've ever been able to. So I really want to take a run at that. So I left 3M after 17 years, and I became an elementary school principal. And by the time, I really wanted to get to kids that were young. I wanted to have this kind of mindset, or have them excited about learning and doing the things, collaborating at a very, very young age. I mean, we're talking preschool, kindergarten, even up through like 6th grade. So I wanted to do that. So I became an elementary school principal. We did a lot of these things. We had a maker program where we had kids that were kindergarten through 6th grade doing, when you think of maker, you think, oh, you're doing robotics. And we did robotics. It was great. We did robotics. But we also did movie making. We did business building. I mean, I still remember, children going up to a big board and presenting their projects to their parents and saying, this is our pro forma P&L. Here's our manufacturing cost. Here's our marketing cost. And oh, by the way, we posted this on Etsy, and we're, because they made a product. And it was great. It was great. And it wasn't things, you do in a day or two. It was you work on it for an hour, 2 or 3 times a week. You put it on the shelf because they're hard. They're things like kids coming in and saying, I have no idea how to do what you just challenged me to do. And then 6 weeks later, presenting their parents and just like, wow, we did it. How did we do that? Well, we leveraged each other. We leveraged online resources, and we were scrappy. So those
Synergy,
kind of things.
yeah.
And then, like I said,
Sorry.
customizing education. There's a place for online. It's not everything shouldn't be online. I think COVID taught us that you don't want to be 100% online, but there's a place. So we had 6th graders that were doing calculus because they were on Khan Academy and they were individually challenged because they could, and others that were struggling, and it was really personalizing. We're actually involved in a school in Uganda right now. Is actually south of Kampala, where where AIDS really started, one of the poorest places on the planet. And with Starlink now, they finally have internet, and we're starting to customize education for students there, because it used to be write this English sentence, everybody read it together. The 60 kids that were in the school with one teacher, and now we're trying to say, okay, how do you customize that for each child? So it was a long answer. So, I did that for a while, and I'm still engaged in education. I'm back at 3M. I love what I'm doing, but I'm still engaged in education. I will continue to be engaged in education.
One more, maybe selfish question. I'm a dad of 4 young girls. Do you have any favorite projects or any sorts of challenges I could give them to get them to, hopefully collaborate more and do a bit of what you're talking about?
Very cool. I don't know your girls. You have to find out what they're interested in. The most expensive thing that we bought for the schools was Lego robots. And if they're at all, so we would buy these kits, Lego robots kits, maybe $300. And that's pretty expensive for some people. They can't afford it. But it was amazing. So a simple exercise we do, and we did this all the way down to kindergarten, is we'd have a big gymnasium, the gym floor, and we just put objects out. And your job is to program that robot so it can navigate through that obstacle course. and they'd have to go to their computer, and it's all graphical kind of programming, but there are loops. There's if-then loops. There's all the structures you have in computer programming, but it's all graphical. And we would have kindergartners, they would take their robot, they'd put it on the starting line, they'd run it, and it would do something wrong, and they'd grab it and run as fast as they can back to their computer to change something, download it to the robot, and they'd run as fast as they can. And it was like, wow, I mean, it was so motivating. And you talk about iteration, there was your iteration. It was really cool. Now, will your girls be interested in that? A lot of kids really are. That's why we tried to do different things. So movie making, for instance, maybe somebody's interested in making movies. You have to come up with a whole script. It's pure creativity. There's the technical part. It's whatever their thing is, but it's a project. It's a hard project. So it's all based on what your girls are into.
Okay.
And what happens, by the way, the Lego robots, kind of engineering geeks like the two of us, I start going, and suddenly they're in bed, and I'm sitting there.
Right? Oh, 100%. That will definitely be a thing for me. I had to clear away all my projects to record this. When it comes to engineering teams, how do you try to foster that sort of creativity and collaboration in your R&D teams in a adult corporate environment?
It's a great question. First of all, you hire people that are collaborative and creative, and also, depending on the industry, people that have a passion for what you're doing. We're talking about electricity here. Is there some kind of, we talk about what's your why? What is their why? Is there something there that they really enjoy? And it could be just the technical part of it. There's great technical challenges. I love that. Or it could be, okay, I think global climate change is a problem, and I want to do something about it. So first, get the right people. Second is a collaborative vision, or a common vision. So working together as a team. Do we know where we want to go? And it's not just the leader, saying, "Hey, this is where we need to go." It's if you hire smart people, they absolutely want to be part of that. So how do you come up with a common vision together? And then we have something called the McKnight Principle in 3M, and really William McKnight was our CEO for, I'll get the wrong number of years, but it was a long time, 40, 50 years. And we still have it at our innovation center. It's posted there, and it's essentially hire really smart people and kind of get out of their way. And if they're going to make mistakes, but if you overcritical of mistakes, it's worse than being. You don't want to be heavy-handed. And that's kind of how I manage, and I've seen that tends to work. You hire good people, they understand where you're going, you're helping, you're removing roadblocks, but you can just see the collaboration, and you can see it just builds on itself. So that's how it works. And in a company like 3M, we're a big company. One thing we do really well is that's not only in your individual group, but it's other divisions, our corporate labs, and geographically. I mean, we're collaborating. We spend a lot of late nights and early mornings in meetings because we're collaborating globally. So it's very, very boundaryless. And that's kind of the secret sauce of 3M. Hire technical people, let them do their thing, and be boundaryless, and they share really well. So there's a few things that we do. And I'd be remiss to not say this: a high degree of engagement with customers. Absolutely. And in this industry, it's great because your audience, it's a total joy working with really smart people that have passions that are similar to yours, that are not in your company, that are outside the company. It's great.
You talked about not being too heavy-handed with failure and getting out of people's way. Have there been any projects where you maybe had some concerns about where it was going, but they, snatched victory from the, well, it looked like
or snatched defeat from the jaws of victory?
Well, hopefully snatched victory from the jaws of defeat.
Oh, the other way around.
Yeah.
Absolutely. I've been on several. I'll do one that I wasn't on, but I worked with the people that were on it. We have a product called ACCR. It's aluminum composite conductor reinforced. It's essentially an electrical cable that you can string, and it basically can carry like 2 to 3 times the amount of current for a given amount of sag. So if you have a river crossing, or if you're going through a city and you need more capacity, instead of stringing up a second set of lines and having the right of way, you just restring with this. My understanding, this happened in the 90s is where we really did the development. And it was on the chopping block probably 20 times. It was just like, this isn't going anywhere. It's not getting any traction. And, a colleague of mine, was kind of the champion behind it. And he saw the vision and his team saw the vision, and they were just persistent. They were just really persistent. 3M's pretty good about that. We need to prioritize too, but we have something called 15% time. So 15% time says, okay, you have 15% of your time that you can do these side projects that maybe haven't been prioritized and so forth, or nobody's even thought of oftentimes, but you feel strongly about, and you can work on those. So some of these things go back into 15% time, and they keep incubating, and now it's a great product. And you can go right on down the line with Scotch tape and Post-it notes, and they all have this kind of story behind them, where some passionate people kind of persisted, even though it was on its deathbed a few times.
So what is 15% time?
Yeah, you hear a lot about this. If you look at like a press on business development and so forth, you'll see this in a lot of books. What it is, it says, if you hire really smart people, you should let them, do what they do best. And a lot of the time it's going to be, we've decided as a division, as a group, where our strategy is, and we're going to do those things. But there's always some other things that are interesting to technical people. And that's what 15% time is. So 3M has a policy that, nominally about 15% of your time as a technical person can be spent on these kind of things. And typically it's not alone. It's you're collaborating with some other people that see a need in the marketplace, and they see some technologies we could apply to it, so they nominally can spend 15% of their time on it. And it's been extremely successful. If you look at some of the innovations in 3M, you look at Post-it note or Scotch tape or all these kind of things, there's the kind of a 15% story behind a lot of these. Now, 15% time isn't it's not 14, it's not 16, it's exactly 15. It's more of a philosophy. It's really a philosophy of a certain part of your time, you can pursue these passions that you think, can make a difference. There's a ton of examples on this. One recent one, which is really interesting, that's still kind of being developed, is a passive radiative cooling film. So if you need something that needs to be cooled, but you don't want a chiller or so forth, you can actually take a film. It's not this film, but the film, any kind of material is, if it's out in the sun, it's going to be absorbing so much of the sun's energy, but also any body is also emitting at the same time. So if you can design the materials, first of all, to be very, very reflective, you're not taking on very much sun's energy. And 3M has some great technologies. We can make films that they're 100% polymeric, and they're the best reflectors in the world, much better than glass mirrors with silver. But also we have materials that emit, and basically what they're doing, they're exchanging radiation into the sky. The sky is a big heat sink. It's cold. So it's putting that out there. And this is no different than when, so if we're in Minnesota, even this time of year, it's 35 degrees Fahrenheit. I wake up in the morning and I have frost on my grass. It's above freezing point. Why is there frost on my grass? And the reason is because all night those blades of grass have been emitting radiation into the sky, and they're actually colder than 35 degrees Fahrenheit. So this is no different. So where does this have value? If I have any surface I want to keep cool, I have a bus, and I want to take the load off the HVAC system. I line this on the bus, and it's radiating that heat out. I have any kind of enclosure like a bus stop. I have things like, you can even put panels, and we've demonstrated this. If I have a rooftop at a grocery store or whatever, and I want to generate electricity, I said, I'm going to put solar on there. It's actually oftentimes better to use that real estate to put panels of this and then tie it into your air conditioning system. So you're basically reducing the load, electrical load, more than the electricity you would have generated with your photovoltaic, your solar panels. So really cool. The question was 15% time. All that is 15% time. It's people, this takes place in our corporate labs, saying, wow, we have these technologies. Let's try them out. What could we use them for? Let's optimize them. Yeah. And then it's, okay, then you get some divisions involved and say, whoa, this is really cool. These customers are interested. Do you want to commercialize this product? And that's how it works.
Yeah, I never thought about solar panels being less efficient than just a really good radiative cooling system.
Yes, it's very interesting.
Are there any maybe less practical, I think like the automotive industry does concept vehicles as kind of a like, wow, that was cool. Do you have any 3M type examples, maybe something in the museum that people always stop at, or any like personal favorites?
There are a couple. There are a couple. I guess the one that we always point to at the museum, we call it the Innovation Center, is I'm going to get it all wrong, but Michael Johnson, the sprinter, was in the Olympics, and we actually his shoes had 3M materials on them, and it's a really, really bright gold. I mean, they just shine. They're beautiful. To this day, they're beautiful. They're still there. So that was an interesting one.
That's a cool one. Yeah.
There's a practical. Is Nike going to take that up? Unlikely, but it was kind of fun. We do a few of those.
What about things that are maybe less flashy? So you mentioned like power cables spanning a river. Are there any things out there in the world that people are surprised to find 3M products in? Maybe things they use all the time, or that are like hold up critical infrastructure?
Almost all the time. There's so many examples. A really good one is we make an acrylic foam tape called VHB. It originally stood for very high bond. And this stuff is amazing. You can hold up a lot of things. I mean, it's funny when you go to a trade show, we have I wish I had it right here. It's like two pieces of clear plastic, and there's like $100 bill enclosed in there, and it's sealed between the two pieces by this, and there are handles on the outside. And it's if you can break this, you get the $100 bill. There's just like absolutely no way. And you look at the stuff, and it's not sticky, it's not tacky. The energy is being absorbed. We talked about energy absorption in the material. VHP is a wonderful product. So, for instance, semi-trailer trucks, the side panels can be, instead of using rivets, which are stress concentrators, you use this. There are basically curtain walls, the big glass on high-rise buildings, the whole glass walls bonded by this. So that's one that people would say, what do you mean you taped up these huge pieces of glass? Well, actually, it seals, it absorbs that energy, absorbs the vibration and shock, and it's the best. I remember a picture. It was one of the hurricanes. I'm going to forget which one it was, but unfortunately, there were semi-trailer trucks just like all over the road, and there were tornadoes that came out. It was just awful. It was awful. But the panels were all torn off, and then the ones that you could see that the panels were still on there, and they went back. They said, "Well, those are VHP." it stuck. I'm not making any claims here, by the way, but it's really interesting. So that's one that people say like you're never, you're always within 10 feet of a 3M product, and most of it you don't know. I'm looking at a screen right now to you, and there are many films in that screen. They're 3M products for brightness enhancement, which ultimately means lower energy, by the way.
So we've talked a lot about trends in motors and battery. Are there any other sorts of trends that you see today that get you really excited for the future?
It does, yeah. 20 years ago when I started working in things like wind energy and solar energy, the problem was intermittency. So, the wind doesn't always blow and the sun doesn't always shine. So if you're going to have a lot of wind and solar on the grid, it just won't work. You need what they call baseload power, and people are listening to know exactly what that is. So everybody said, well, energy storage. We need large systems of energy storage. And it never really took off. There's what's called pumped hydro, but there's always been competing technologies. What's exciting now, because of electric vehicles and because lithium-ion battery packs and the prices have gone down so fast, now that stationary energy storage or large-scale energy storage, like for a city, have really started to take off. So it's a really exciting time that you can leverage what the industry is doing in electric vehicles, apply that to these stationary energy storage systems, which has a huge impact on how much wind and solar and other renewables you can get on the grid. So really, really exciting times there.
So how would you think about, and what sort of trends do you see in like the world of vehicle to grid versus or as compared to a more static grid storage, a dedicated grid storage system?
Yeah, great question. What I'm seeing is I'm seeing the static grid storage solutions are actually growing faster. So if you go to like the RE Plus show, which is renewable energy, now half of it is stationary energy storage. So that's really taken off quickly. If I would have guessed this 20 years ago, I would have said that vehicle to grid would be bigger. We know that some vehicles like the F-150 Lightning do have bidirectional, and more will have bidirectional. But we're not seeing it so much. It'll be interesting to see how this plays out. Maybe part of the issue is, your vehicle battery is, a really expensive component. And, even though there isn't a huge amount of degradation, you do get degradation over time. And using it as the backup for your home, for instance, you will degrade a little more over time. So it'll be interesting to see how that plays out. If there's more, I think it's been vehicle to grid has been kind of slow developing right now.
It seems like people are more willing for the vehicle to grid approach to power their own home and less willing for it to help power a industrial.
Putting it on a microgrid or something like that. Yeah. I think that's true. I honestly, personally, as an electric vehicle owner, I think it's great because I'm actually considering a residential energy storage, and I think that's probably where it will play. I think exactly what you said. I think for residential storage, vehicle to grid could be big, but surely not for larger. You just need larger storage, which is interesting too. Just as an aside, so lithium ion, you have these primary cells that your storage. You just have the cell itself, and all the energy is in the cell. So you really get kind of limited capacity. So limit the number of kilowatt hours. You can deliver high power. But if you really need long-term storage, that's where things like pump hydro were great. There's also things called redox flow batteries, where basically you have the cell itself is where the electrochemistry happens, but then you have your analyte and catalyte in big tanks, and you can increase the amount of energy just by increasing the size of those tanks, which is really interesting. Since lithium-ion prices have gone down so fast, lithium-ion has taken off for stationary energy storage faster, but there's other ways that you can get more energy, if you will, more capacity. And it'll be interesting to see what happens with things like redox flow, or there's things like, mechanical. There's things like, lifting concrete slabs and bringing them down and stuff like that. It'll be interesting to see how it plays. You asked the question about, what is really exciting. That's an area that's really exciting. This longer term energy storage, even medium-term energy storage, and that's going to be very big and very important in the future.
And there's so much need for it and so much potential for innovation. It seems like a great place to, spend 15% of your time ideating.
Absolutely, and it's an adjacency too. So, essentially we're providing materials that go into a battery pack of a vehicle going down the road. The battery pack that's sitting in a large shipping container kind of structure that's powering a city or part of a city is, quite similar, but it also has its unique challenges. So, what little different technologies do you need for that is the question.
Well, we're about out of time. I like to do a quick question or two at the end of these. First question for you. If you had a magic wand and could change either a law of physics or a inherent materials property, what would you do with that magic wand?
Superconductivity. That's a good one.
That's my answer too.
Is it really? You're an electrical engineer. That's cool.
Yeah, I know.
It's so, let's see. Lawrence Berkeley National Lab. So the Lawrence Berkeley National Lab has this one chart that people know. It's the United States. It's all the, the sources and sinks of energy. And if you look at the line losses, it's amazing the line losses and how much energy is essentially wasted due to generating heat in these lines. Yeah, superconductivity would be great.
Yeah, I got really excited when they thought they had room temperature superconductors recently, like the last 2 years, and I was really disappointed to hear it was not. So I'm glad to hear you say that. If you had a set of engineers, you had a set of young engineers or early career engineers and a set of more experienced engineers, and you were going to build a day of learning or a day of enrichment for each of them, what would you put in their curriculums?
That's great. Let's stick on the same theme. Let's stick about electric vehicles. I want you to, we're going to take blocks and so forth, and I want you to build a battery pack for an electric vehicle. And I want you to optimize the performance of that. I want to optimize for cost. I want to optimize for performance. I want to optimize for safety. And you design that. So you got to think about, things like thermal runaway and venting. You need to think about electrical insulation. You need to think about this. And we're just going to do it with big blocks. And then at the end of the day, we're going to show everybody our design and why we designed it that way.
I love that.
It brings kind of an elementary kind of thing, but it brings in some pretty good science too.
Sounds very fun and a great way to learn through doing and learn through mistaking potentially. So.
Yeah.
Wonderful. Well, thank you so much for being here. This was a great chat.
Thanks, Daniel. I enjoyed it.
That was Mike Strommen, 3M's Global R&D Director of the Electrical Markets Division. Thanks for joining me today in the lobby. If you liked this episode, please share this podcast with a friend who would like it too. That's how this show grows, so we really appreciate it. And also, we're gearing up for a new season. So if there are any topics, technologies, companies, or guests you'd like to see next, let me know over on the Moore's Lobby social channels. I'm your host, Daniel Bogdanoff. Thanks for tuning in, and I'll see you next time.